y equals x squared minus 4x plus 3. And they give you the graph like so. All right. Okay. All right, so at 1, the parabola is right here. At 2, oops. Sorry, my alarm went off. 2, okay. Where was I? Yeah. At 2, it's over here. At 3, it's right there. So it has this kind of shape. It has a point right there. At 4, it's at 3 as well. Okay. There's something like this. And then we have a line. So that's the parabola. And you have a line that goes through here and here. So the shaded region is this. So they can give you the picture, so don't worry about it when you do the review. It is much prettier than this. So what we said, we choose a slice. If I choose vertical, then it's going to be dx. So the slice looks like I hit each function once the entire way. It doesn't hit the same function on the top or bottom multiple times, so we're good. So dx, so we're going to do top function, which is y equal to x minus 1, minus the bottom function, which is x squared minus 4x plus 3. So I'm going to integrate from 1 to 4. Okay. So start off, simple question like this. Let's see what happens. 1 to 4. So we subtract that and we would get negative x squared plus 6x, 5x. 5 minus 4 is plus 4. 1 plus 4 is 5. Negative 1 minus 3 is negative 4 dx. Do your integral, and we get negative x cubed over 3 plus 6x squared over 2 minus 4x from 1 to 4. Okay. So plug it in and subtract and we're good. So it'd be negative 4 over 3 cubed plus 3 times 4 squared. Let me see. Oh, right. Thanks. That's negative plus 5, yeah. So it'll be 5 times 4 squared over 2 minus 4 times 4 minus negative 1/3 plus 5/2 minus 4. Okay. That'll be what? At this point, to save time, we'll use our calculator. But let's double check everything. Yeah. Should be 9/9 on your answer choices. Yeah, here it is. So your first couple of the questions will be just find the area between the graphs. This one you have to graph yourself, but the first two, I gave you the graph. But note that here we'd have to do 2 integrals, right? One for this section, one for that section. Any questions on the first one? Okay. All right, let's move on to volume, because the area, I'm hoping most of you got that down already. If not, please practice those area questions. Find the volume of the solid generated by revolving the shaded region about the given axis. Okay. All right. And they give us this graph here. I'm going to show it to you so we don't have to. Well, no, it's fine. I could draw it. It's not a hard graph. So we're revolving this way. Okay. It did not tell us to use any particular method. So you could do shell, you could do disk. It's whatever. But since slicing vertical is perfect, right, for dx, we have the range from 0 to 4. So why not use disk? One moment. Let me pull out my formulas to make sure I don't mess it up. I don't use, in all honesty, the disk washer shell doesn't really come up very often after this class. But it is an interesting idea as to how they developed a lot of the software that finds volumes and areas for you. It's all based on these formulas. Okay. So the volume will equal to pi times the integral of a to b of r of x squared. So the radius squared, we simply find by subtracting the top minus the bottom. So this will be pretty easy. Integral is dx, so we'll be going from 0 to 4. And that function needs to be given to us. Let's see what it is. Yeah, they said that y is equal to 16 minus x squared. 16 minus x squared. Yeah, so Garrett, yeah, you can use any method. If you use it appropriately, you should get the same volume. Because if I were to slice this way, I would be required to do shell because it's parallel to this axis of rotation, right? So then I'd have to set it up that way. So it'd be going from 0 to 16 on the dy, and then I'd have to solve for x in order to get it in terms of y, and then find my shell height and shell width. And yeah, it should actually work out pretty just fine. You'll notice that certain methods are easier than others for certain problems. So if I don't tell you what to do, pick the easiest method. Sometimes shell is easiest, sometimes disk is. If the question says you have to use shell, then life sucks, or especially when it's not easier, right? But anyway, I'm not saying shell is hard. I'm just saying shell could be hard depending on the problem, or same for disk. Sometimes disk is a pain. Square this. All right, so 16 squared, what is that? I don't know what that is. No. So FOIL this out and you'll get 252 minus 32x squared plus x to the 4th dx. Okay. So we'll just integrate that from 0 to 4 and we're good. So that'll give us pi times 252x minus 32 thirds x cubed plus 1/5 x to the 5th. So that'll give us 8192 over 15 pi. So that'll be this one here. Now, one moment. Sorry about that. Someone was knocking. Where was I? Okay. So let's see here. This guy, you could easily do shell or disk. Doesn't matter. They're rotating about the y-axis, so it's going this way. So if I were to slice up and down to get dx, I would have to solve for y. And then, okay, sorry. If we were to do horizontal slice, that will be perpendicular, so that would be this method, which will allow us to use this equation, so we wouldn't have to solve for it. So I think both are simple. Also, technically, this is a geometrical shape. You could just find the area using geometry, right? And then use that to help you find the volume, but that would be cheating. But anyway, I think that one seems kind of simple. Do you guys want to do this one, or does it seem easy enough? Okay, we can do it. All right. Is it me or does the screen look messed up? I don't know if it's just my end. Does it look okay? Okay. Yeah, this must be on my end. Everything looks blurry, but as long as you guys can see it, I'll just ignore it. Okay. Find the volume. Move this equation here. Move this of area revolved. Okay. Alrighty. So they said that this is equation for this line, the horizontal x equal to 5y thirds. And we're revolving this way. So since it's already solved for x and neither method seems to benefit me, I'm going to slice this way. creating a shell situation because it's perpendicular. So the integral from 0 to 3 is 1, 2, 3 there, from the y, the right being 5y thirds minus 0 squared dx, and there's a pi, right? Okay.
Quick question: where did the minus 0 come from?
Oh, so it's the bounded region is this, right? So the right side is a line minus the left side, which is the x equal to 0. So the boundary is this, right? The vertical line. You see what I mean?
Oh, I got you.
So, I mean, you don't have to put that. I just do it just because I want to put the right side of the region and the left side of the region. That's how I'm always going to do it, just in case it's not 0, right? Just in case it's like some other function or something.
Okay, got you.
Okay, so it'd be pi 0 to 3 of 25y squared over 9 dy. It's a y. So the integral doesn't seem too bad, right? So integrate that guy. That will be 25y cubed over 27 from 0 to 3. This should give us about 25 pi. Yeah, pi. So not too bad, right? So far.
Not too bad.
Alrighty. So after that, they stopped giving us pictures. So you're gonna have to graph it yourself, and I'm gonna make sure you have Desmos active during the exam. Now that I know how to do that, let's see here. Okay. What was I doing? Yeah. So this guy doesn't tell me what to use, so I can use whatever I want. Simple things to graph. Let's see here. This one looks challenging because they're let me see, region in first quadrant. Yeah. Revolve about y equals 3. So this makes it a little harder because I'm away from the it's not the axis may not be right next to the graph or the region. So let's do this guy. So should be 6 pi. Let's see if we can get there. Okay. Oh man, I'm out of paper. Okay. Find the volume of the solid generated by revolving the region about the given line. Alrighty. So first quadrant bounded region is in the first quadrant bounded by y equals 3. Okay. Well, yeah, let me use the graphing utility. That way we can get an idea before I mess it up on paper. Okay. Well, let me write down the equations first. Y equals 3. Y equals 3 halves x, or 3x over 2, same thing. And it also says by the y-axis, which means technically x equals to 0, right? All right. So let's graph all this nonsense. Okay, so we got y equals 3, y equals 3x over 2, and x equal to 0, which is the y-axis. So it looks like it's going to be this region here, right? And they're revolving it around the red line, so going this way. Okay, but since the line is right next to it, we can, it won't, if we use disk, there won't be any donut holes. But anyway, if I'm revolving this way, cutting up and down would allow me to do shell, and everything's already solved for y. I'm sorry, disk. If my slice is perpendicular to the rotational axis, then I would have to be doing disk. So let me graph this picture here. Zero, 0, 1, 2, 3. 1, 2. Make that better. I can do better than that. 1, 2, 3. So you got a point there, a point at 2, 3, a point at 0, 3. You got this triangle going on, right? That's my region. We have this line of rotation over here. We got x, we got the y-axis. Find this volume. Right? Okay. So since I can do slice parallel, and I don't see any benefit into doing shell, it actually seems harder for this question. The other ones, it was the same difficulty, but this one slightly harder because I just solved for two things, but that's fine. So formula is pi times, so since I'm doing these types of slices, it'd be 0 to 2, right? It'll be top minus the bottom, so the top is no longer 0, right? So that means I got to put 3 minus this function. This function technically goes on forever. Right? All right, follow this out. We get 9 minus 3 times that is 9, 18, right? Yeah. Okay, integrate this guy. We should get 9x minus, this is a 9, so that'll become 9 over 2x squared. That'll become 3x cubed over 4 from 0 to 2. All right, see if this comes out. Let's double check. All right, so be 9 times 2 minus 9 over 2 times 2 squared plus 3 times 2 cubed over 4 minus 0. So this will be 18. Oh, don't forget there's a pi. I forgot about it. Hopefully this all turns into 6 pi. Otherwise, I'm just going to go to sleep and give up on life. I'm just kidding. There we go. Okay. 18. So that reduces, right? So minus 18 plus 3 times that. Yeah, 6. Cool, worked out. There we go. Sorry, got kind of messy there. Anyway, you see how we set up the problem and how we set up the integral. Okay, so the next problems force you to do shell. They no longer say do whatever. So we gotta use shell method. Shell method. Let's do, I guess that one. Let's do that guy. Any questions on the last few problems? You guys doing okay? No, yeah, I'm out of paper. Let me use the paper without lines. Use shell method to find the volume generated by revolving the region bounded by the following. Okay. So the answer is supposed to be 3 pi. Let's see if we get it. Let's make sure. Yeah, it's y equals 3. Okay. Yeah, so this graph looks good. So it looks like we're going to be in here. And we're rotating on the x-axis, so we're going down this way. All right. And they want us to do shell. Okay. Okay, so the graph was here and at 1, 3 here, and 0.5 and 3 here. We had a line going this way. So we had a line there and here. So we care about this little section. Okay. All right. Use shell method about the x-axis. We're going this way, meaning I have to slice parallel to it, right? To do shell. Which means I need to solve for x. So this implies that x is equal to y over 3, and x is equal to y over 6, right? Okay. Alrighty. One moment. Okay, still think check this here. Then it'll be from 0 to 3. So the inner radius and then the outer radius, right? Be these guys. So the inner one will simply be the right minus left, which will be the right side. I forgot which one's which. Can't tell by the drawing. Let's look at our graph that we made. Okay, so right minus left is the 3x minus 6x. In other words, y over 6 minus y over 3 times this radius times that radius, which will be the rotational axis. Let me think. Let's forget. I think it would be just y. Let me double check though. Yeah, should be. think it may be, shoot. Is it y minus 0 or 0 minus y? Let me check my notes. 1 second. Try that out. See how it comes out. Might as well try it. Okay. All right. So I believe there's a 2 pi in front of this formula. So that will be the integral y over 6 minus that would be negative 3 over 3, sorry, 2 over 2. So 1 minus 2 is negative y over 6 times negative y dy, which should be y squared over 6 dy. Okay, that'll be our integral. So this will give us 2 pi, which is really just pi times, reduce that 18 there, 2 cubed over 9 minus 0. So that should be 2 times 2 times 2, that should be 8 pi over 9. Let's feel like I messed something up. Let's find out. What was I doing? Oops, yeah, that's a 3, my bad. 0 to 3, 3, 3. So that would be 27, right? Which would be 3 pi. All right, came out. I was worried there for a second. Anyway, any questions on how we set this up for shell method? Okay. Okay. You guys feel comfortable with the shell method? Anyone having issues with it? Okay. I'm going to move on to arc length, if that's okay. I'll leave the rest for you to practice. So arc length, for some of them, I'm just going to have you set it up and see how you just set up the question and you're done. Okay, so you probably have one of those on the exam because the integral might be too long or whatever. But then you'll have one where you actually do solve it. Okay. Okay. 2x to the 3 halves from x equals 0 to x equals 5/4. So we need to find the derivative, right? The formula is for arc length. That's equal to the integral from a to b of the square root of 1 plus the derivative square, right? Dx. So the derivative, so if f is this, f prime is 3x to the negative, what is that? No, actually positive 1/2. Okay. So squaring that would give us 9x, right? So arc length would be the integral from 0 to 5/4. It's an ugly 5 of 1 plus 9x dx. This integral looks pretty easy. Let's do a simple u sub, right? This would be u 1/2, right? If we let u be 1 plus 9x, du would be 9 dx. So du over 9 is equal to dx. So I'd have that here. Du over 9. So that would be 1/9 times, if you integrate this, that would be, add 1 3/2, so it would be 2/3 u to the 3/2 from 0 to 5/4, but those bounds are for x, so let's go ahead and change it. That would be 2 over 27 times 1 plus 9x to the 3/2. Okay, so plug that in, and you should get 1 plus 9 times 5/4 to the 3/2. That looks really ugly. Let me fix that. Ah, shit. Minus 2 over 27 times 1. All right, so let's use our calculator here. Let's see here. Because that would be 2 over 27 times 9 times that would be 1, 4 over 4 for the common denominator. 9 times that would be 45 over 4. times to the 3/2. So that would be 49 over 4 minus 2 over 27. 2 over 27 times, so 49 over 4 square rooted would be 7/2 cubed, right? So at this point, just use a calculator. I don't like numbers. Let's see if I got it. 335 over 108. Yeah, there it is. 335 over 108. Sorry, it's kind of far up there. Any questions on the arc length? All right. Okay, one moment. All right. We have time for this last one here. Find the center of mass of a thin plate. Of constant density. Given region. Okay. So here's the region bound. So the region is, region is bounded by y equals x squared and y equals 3. Okay. So it's just a parabola, right? So right here at 1, 1, 2, 4. Okay, so there's symmetry here, meaning the center of mass, it says it's there's a, okay, so let me start over. Find the center of mass of a thin plate of constant density, meaning the density of the plate will be the same everywhere, right? Since it's symmetrical, then the center of mass in the x direction should be somewhere on the 0. So you can technically spot that x bar will be 0 without doing any work. You see what I mean? The y bar will require some work, though. To like where exactly is it going to be on? So it's somewhere on the y-axis, the center of mass of this plate. I know it's 0, so I'm on the x, but where on the y? Is it up in the middle? Down here? That needs to be calculated. All right. So we got two functions. We'll say f of x is x squared. F of, g, we'll call it g of x the y part. Okay. So we know that the capital MX is equal to, shoot, what was that? P part. 1 second, let me get the formulas out. Yeah, it's going to be P or rho, I forget what the book calls it. A to B. Of f of x plus g of x over 2 dx times, I forget, times f minus g. So this will be the integral from, we could do 0 to 2 and double that, right? So let's put a 2 there. 0 to 2, since it's symmetrical, make the integral easier. Be x squared plus 3 over 2 times x squared minus 3 dx. Okay, so that'll give us 2p, or rho, times x squared, or to the 4th actually, minus 9 over 2 dx. 2. So that integral will be x to the, actually I can cancel these 2's, huh? Nice. That'll be x to the 5th over 5 minus 9x, 0 to 2. Now don't forget my p, I guess. So that would give us p times 2 to the 5th. What is that? 32? Is that right? Yeah. Minus 0. So there's my mx. Now I'll need my small m, because the formula to find the y bar requires mx divided by m, where m is just the difference. this piece here, the integral of this guy. So m, little m, is equal to the integral from 0 to 2 times 2, since I'm using symmetry, of x squared minus 3 dx. So that would be equal to 2 times x to the third over 3 minus 3x from 0 to 2. Don't forget my p. There should be a p here, 2p. Yeah. This is little m equals to 2p. So this should have a 2p right there. So the integral will be, that's good, plug in the 2. So it'll be 2p times 2 to the third would be 2 to the fourth, which is 16, minus 6. Okay, so y bar would equal to capital Mx divided by little m, which will be this p thing, 32 over 5 minus 18 over, here we go, 2p times 16 over 3 minus 6. The p's are gone, thankfully. Let's see what the hell that is. All right. It's negative 58 over 5 divided by negative 4/3. And it gives me 87 tenths. I think that might be off. Let's check. Yeah, I'm a little off. Let me check my work. Squared minus 3. X to the fourth minus 9. That's right. Integral's good. 2 to that's 32/5. 32/5 minus 18. 32/5 minus 18. This integral is cubed over 3. But there's no 2. Shoot. There's no 2 here. Did I bring that 2 in by accident? Dang it. Now change this. All right, so this should be 2 to the third, which should be an 8 right there. So this bottom part should be 8. All right, let's see if that fixes it. Okay, top part looks good. So that was negative 58 over 5 divided by negative 20 over 3. Top part was fine, right? That's weird. Yeah, this part's fine. Yeah, one moment. Let me check my formula here.